Let us discuss about the shape factor, obtaining shape factor for an triangular section. So we'll consider a triangular section as given. So of ABC, ABC is a triangle. So of breadth B and height H. So for that, as we know that for a triangular section, center of gravity about center of gravity, what is moment of inertia, which is equal to bh cube by 36, and about the base B we have moment of inertia which is equal to bh cube by 12. So now we'll find ZE and ZP, so that we can find ZP by ZE to get the shape factor. So ZE is equal to I by Y. I is the moment of inertia about center of gravity, CG, that is BH cube by 36, divided by Y. Y is nothing but this distance. So it is 2/3 of H. So y is equal to 2/3 of H. I am going to get the solution as BH square by 24 on simplification. Now we have ZP is equal to formula A by 2 into Y1 bar plus Y2 bar. So to find ZP, now I have to first determine the equal area axis. Now I'll consider this as equal area axis, EAA, equal area axis. Now once you consider this as an equal area axis, and if I draw the figure like this, so for this figure, this is an equal area axis, EAA, of breadth B1 and height H1, whereas this breadth B and height H. So both are similar triangles. By concept of similar triangle, we'll get B by H is equal to B1 by H1. B by H equal to B1 by H1. On rearrangement, we get B1 by B is equal to H1 by H. I'll consider this as equation number 1. Now we will consider as it is an equal area axis, so half into B1 into H1 must be equal to half of half into base into height. So I'll consider that one. So we'll get B1 H1 is equal to BH by 2. And based on this equation, equation number 1, on simplification and arrangement, I'll be getting H1 into H1 by H equal to H by 2. So on simplification, I got H1 is equal to H by root 2, B1 is equal to B by root 2. So I got H1 equal to H by root 2 and B1 equal to B by root 2. Now I have to solve for Y1 bar and Y2 bar. So solve for y1 bar and y2 bar. So how to solve for y1 bar? So it is very simple. From this figure, it is clear that so y1 bar is nothing but h1 by 3. h1 by 3. So 1/3 of distance. So y1 bar is equal to h1 by 3. So as h1 is equal to h by root 2, h by 3 root 2. So this is equal to y1 bar. Now we have to find y2 bar, but to find y2 bar, this is an trapezoid. So for that we have a note. We have a note. So for the trapezoid given like this, of height A and base width B1, or and top width B2, we have formula as this distance. For this distance I'll take y bar. So y bar is equal to a by 3 into B2 plus 2B1 divided by B2 plus B1. This is the formula. So based on this substitution, I can get the y2 bar. So here, instead of B1, we have B, and instead of B2, we have B1. To find A, here in this figure, in order to find this A, which is simply capital H minus H1. So A is equal to capital H minus H1. So we get y2 bar is equal to capital H or H minus h1 by 3 into b2 is nothing but here b1 plus 2b divided by b1 plus b. On simplification, you can substitute b1 as b by root 2. Here also b1 as b by root 2. On simplification and substitution, we can take it as y2 bar is equal to h minus h by root 2 by 3 into b1 is nothing but b by root 2 plus 2b divided by b by root 2 plus b. So it is, I can take h out, here, so it will be 1 minus 1 by root 2 by 3 into, I can take b out here and also here it gets cancelled. So remaining I will be having 1 by root 2 plus 2 divided by 1 by root 2 plus 1. So I'll substitute all these things. So I'll get in terms of h. So on substitution we get one minus 1 by root 2 divide with 3. So I'll be getting value as h into 0.0976 into this value I'll be getting as 1 by root 2 plus 1 upon simplification. I am getting y2 bar to be as 0.1548 h. Similarly, I have y1, so this also I'll substitute. Y1 bar is equal to h by 3 root 2. So I have 1 by 3 root 2. It is 0.2357. So 0.2357 h. So I got both in terms of h. So now I can find Zp directly. Zp is equal to a by 2. So a is nothing but bh by 2 is the area divided by 2 into, I have y1 bar plus y2 bar. So y1 bar is nothing but 0.2357 h plus 0.1548 h. So I'll be getting this as bh by 4 into the h I can take out, so it will be bh square by 4 into this particular value will be 0.2357 plus 0.1548. So I'll be getting the value to be as 0.3905. 0.3905. So this will be the value for Zp. So Zp is equal to 0.097625 into bh square. So I have already found Ze value here. So I am going to substitute Zp by Ze to get the shape factor. So therefore, shape factor for a given triangular section is equal to ZP divided by ZE. So this is 0.097625 BH square divided by BH square by 24. So I'll get BH square gets cancelled. Upon substitution of this value, we will get 2.343. So shape factor is 2.343. So hence shape factor for a given triangular section S is equal to 2.343. This is how we have to